We'll now begin with the earthquakes and mounts panel discussion. And I thought I'd lead off with the first thought that goes through my mind when I'm designing seismic mounts. That being, what can go wrong will go wrong. So putting it out to the rest of the panel, any choice words you guys have to live by?
I would say take everything into consideration. There's a lot of complexity.
I know I felt very, in listening to Ted and to Monica, I really liked the concept of kind of the chain of custody in terms of, you know, what is the base attached to, what is the wall attached to, what is the floor doing? Because to me, it's all about, you know, how are the forces of support being, you know, all carried. So I really appreciated as you kind of went through that litany of what is attached to what.
Yeah, I totally agree.
I was really fascinated with Vincent's approach because you know, we wish we could consult engineers more, but I really liked sort of how you were thinking the same thing, but in a much more scientific way and more precise way, looking at the weight of the sculpture and then approaching how you did your mount that way. I wish we could do that more often and that we had more knowledge about the building. And because we have 5 different buildings, we're not as knowledgeable about each foundation or each construction aspect.
Yeah, well, I was very fortunate. I've been really, really lucky that I've had, you know, we've had our building engineered and everything. So it's predictable what our floors will do. We have like acceleration for every floor, and it was interesting too. In just that, we have 4 floors in the building, and the 3rd floor has the greatest amount of acceleration. And so and if you think of it as like doing the hula, it's like that. You know, it's as the further you go up, every floor will have a different wave that hits it differently. So even in our building, it's very eccentric, and I'm just lucky that I've had the information to work with. And then we've had, like, I think you were talking before about, I'm not sure if you were referring to accelerometers, but you had things that were testing the vibration on the pieces. And so we've had a few of our larger sculptures tested like that, and engineers were able to give us, you know, detailed analysis of the periods of those sculptures. And so we don't have enough money to go through every single sculpture in our building, but I can take that information, compare it to other sculptures, and then look at our floor spectra to see how that all matches up. But we're very fortunate, absolutely, and to be able to do that at other places. It'd be really interesting to find some way. I don't know. I think that's one of the things that we can do as a group, is to figure out some way of creating a system of kind of understanding our buildings, and maybe even, I don't know, you know, funding further investigation into each of our museum structures, because it's so important. I don't know how else to get the information except for just to have an engineer come in and do the analysis.
Yeah.
I was so impressed, Vincent, with your presentation, and I didn't get to ask this question, but obviously for mount makers in large sculptures too, and small sculptures, center of gravity is so important, because when the quake happens, it seems like that center of gravity is connected to the earth in such a way where if you don't find that center of gravity and mitigate the mount or work the mount around that, then things going to go wrong. Yeah, they're going to go wrong. So the question I did want to ask you is, how did you determine that center of gravity on that biomorphic shape? I mean, I can see a cylinder.
I literally made a model of it. I'd saved it, but like I actually even I just got that epoxy sculpt, and I you know, it did with photos and drawings. I made a drawing. I tried to add lead to it to get it's you know, the proper, you know, because basalt is actually, like, you know, much heavier than epoxy. So I just tried my best to you know, to model it as best I could, you know, physically, because I'm not, I'm not great with math, I'm not great with engineer, but I know how to make things. And so I just, you know, by drawings and photographs and physical modeling, that's how I would, you know. And then you know, it's like you have the model of it, and then you just put it on different fulcrums, and you find out, you know, from this angle, like where its center is.
Exactly.
And yeah, it's literally not rocket science. It's actually just brutal, just crunching. You just you know, physical crunching. But thank you.
Well, thank you.
We've got a question that came in here from Kate Kerr. She says, I make mounts in an earthquake zone and often have to work with glass shelving. Do you have any successes in how to discreetly attach to glass? I think Monica and Ted, were the acrylic bases you were using waxed to the glass shelves, or were they allowed to slide?
So that was the thing with the, so some of them were, if they were a broad base and the objects were light, we did not do anything to secure them. And the ones that had the heavier objects that were tall and off, and with the smaller base, like the umbrella handles, we double-sided taped them. We didn't, we just used double-sided tape. And I think if we had double-sided tape all of them, we would have seen a lot more damage. I think those pickle forks and letter openers would have jumped out of the or out of their mounts. And in fact, there was another set of napkin ring holder, or napkin rings, I guess. They're made of ivory. They're just basically rings. And those also were, the acrylic bases were double-sided taped, and those came off of their mounts as well. And so I think you would have to decide on the mounts combo. So if you have a grippy mount that completely encapsulates the object, then attaching the acrylic to the glass would have been fine. But otherwise I wouldn't recommend it. Actually, I would recommend, unless it's going to slide into another object. I mean, obviously you have to consider that, but I don't know if other people, this is what we did for the glass shelving, is we used acrylic bases. But I'm sure there's other techniques.
So the double stick tape worked well.
It did, yeah. It was just the 3M 415, I think, or whatever that number, sort of standard double-sided tape. It wasn't anything super strong.
This is a response to that question, but not a answer as to what to use on the glass shelving. I was advised years ago, if possible, when dealing with design, to not use glass shelving, to instead use plexiglass. Now, then you can mount to it, obviously, but the issue is in an earthquake event like they had in Anchorage, if you have glass shelving, there's the potential that it shatters. The objects drop off it, the glass drops on objects on a lower shelf, et cetera, et cetera. So that was just something I was advised of years ago. But while I'm speaking, I just had to ask a question of Monica and Ted. Thinking back to your photo of the ivory umbrella handles, prior to the earthquake, it looks like you mounted it so it was sort of half surrounded on each side as it stood vertically. Following the earthquake, would you have something that surrounds it entirely? In other words, it looked like it might have moved to one side before it moved to the other side because the mount allowed it to do that. Would you now approach it in a way that would hold it all the way around?
Yes, I came in post-earthquake. I was unfortunate and fortunate at the same time to not be there at the time. I was unfortunate because I couldn't assist in the damage and cleanup. Fortunate I was not there to experience it. But But no, after I was asked to come in and mitigate some of these mounting situations, and these mounts are that's the goal. Is as Vincent brought up about the aesthetics of a mount, I mean, you have to be very careful. You do want to get something that can encapsulate that, but without totally encapsulating it. You know, so there's a point, and there's, besides the center of gravity, there is this point of I call it release. So if you have enough wrap around, you don't have to go maybe more than you need to, and it goes back to the aesthetics of the object, especially on some fine, small objects. And so yes, our mantra is to secure as best as possible around, so that it does not, there's no release points. I see what you're saying. I saw that in the photograph. Yes.
Ed and Monica, one point that you guys brought up, which was I thought was really a good topic, was the fact that, you know, what the kind of damage you saw from temporary walls, and you know, that's something that might not always be taken into consideration, you know, versus a permanent wall or a structural wall in your building. And I'm glad that you brought that up, because it does something that needs to be taken into account of you know, taking that sort of holistic approach, as you know, Jamie was mentioning, and just thinking about all the aspects of how your display is put together. But thank you for bringing that up, because that was a really important point.
I think also, you know, we have like that particular temporary wall was made by contractors who don't normally work for our exhibitions department. It was made by a different company that was, you know, contracted to help for a variety of reasons, and maybe it wasn't on their mind. Whereas the contractors that we use, that the exhibitions department uses regularly, those temporary walls, I think, I don't know, Ted, you could speak to that maybe, but the temporary walls that are that we use in the Chipperfield edition, I think those were made either in-house by Rex or were they made by DBS? But I think, I mean, it made a difference, the people having experience who made the temporary walls. It wasn't just this, you know, people who don't work in museums sometimes don't think about these things.
Right.
And so, I mean, they're wonderful contractors and they build buildings all over the city and state, but they perhaps didn't really think the ramifications through of how easy would it have been to secure it to the wall behind it, which is a structural wall,
Right.
instead of having it in it, because it abuts next to it. It just doesn't, it only is connected at the floor.
Okay.
So Monica, can I just ask a further question there, because it was in our Q&A earlier from Jonathan, but can you talk a little bit more about the case failure versus the object mount failure?
Sure. And I told these lovely panelists before, is I don't like to point blame at any one person, because especially, you know, a lot of the mount decisions were driven by aesthetics and curatorial. So speaking to the glass shelf, as a conservator, I would never agree to a glass shelf, but I didn't have a choice. You know, that was a decision that was made beyond us. And similarly with the kind of approach to the mounts is, you know, I agreed to it. It's my fault just as much. But I think that there's a lot of I wouldn't call it failure, as opposed to a lot of different factors all came together that resulted in this one instance. Because we also, I didn't go into this, but this earthquake was unusual. It was a very jarring earthquake. It wasn't a rolling earthquake. And for those who live in earthquake areas, you know the difference. And we get them all. We have earthquakes all the time. They're constant. But generally, you know, the ones that are the jarring ones are usually when the tensions build up between the plates, and then suddenly there's something that gives. But there's also directional. So that also contributed, is the fact that the earthquake, this particular earthquake, went east-west. not north-south, and that caused damage that we couldn't have predicted. And so I think they all kind of come together, and that's for me, the hardest part about moving forward in the future is trying to think of all those different factors. Because we used to be like, well, they're mostly, we mostly get these big rolling earthquakes. I mean, that is the biggest earthquake since 1964 up here. I wasn't around then. I don't think Ted was around either, or lived up here, and we didn't have experience with something so large. But now, of course, it's different. Now we think, oh, there's going to be another large one. It's probably not going to be another 60 years. It'll probably be less.
Right.
I'd like to loop back to that and something that you mentioned in the presentation about objects not jumping out of mounts. Speaking as someone who has seen evidence of objects jumping out of mounts because they didn't have a vertical restraint, I think it's worth discussing a little more. I did take a little time to look back at that earthquake that you experienced in 2018, which was described as a dip slip quake. So apparently the Pacific plate kind of bent, and you had movement derived by that, but it is a subduction zone that you're in where the Pacific plate is diving underneath the North Pacific plate. And that's where you can get tremendous vertical forces. If you get a subducting earthquake, things have a lot more vertical potential. And I just wanted to make sure people were aware that depending on the type of earthquake you're encountering, you can get tremendous vertical uplift. And of course, you never get to choose which earthquake you're getting. So you don't know what the next one would be, if it's rolling or has a big vertical thrust. But, speaking here from representing the Getty Museum, we always try to provide vertical restraint because we have similar conditions to you, and we feel it's always best to be prepared for vertical uplift and the chance that an object may indeed jump out of its mount if it doesn't have that restraint.
Mac, if I might add it, during the Lowry for AntiQuake, I wasn't here. I came in right afterwards, but I saw the aftermath, and it was described to me in great detail. We didn't have, vertical, giant vertical accelerations on that site, but objects did fly out of their mounts, like heavy objects took off. And so this was the building responding to the input of lateral vibrations hitting the building, and then the building's response was very unpredictable. That's the reason why we moved, because that building was was rated like it was like on the bottom scale of like what should be seismically safe. But yeah, again, we need to not just look at the earthquake, but the building response, and be prepared for, if we can be prepared for almost anything.
And Vincent, I think you brought up a great point in your in your question and answer after your presentation, was that you've got to treat it like it's going to happen at any point, and you can't necessarily pick and choose, like this is a temporary exhibit, or this is only going to be up for X amount of time. I mean, you have to assume that it's going to happen at any point, and
it's going to be on my watch. It's going to
right.
It's like, I don't want to take that responsibility.
No, I'm always happy at the end of an exhibition. I'm like, I dodged that bullet. But but we have to keep that always into consideration. And I'm glad you brought that up.
Well, Monica, I just want to say, Monica showed this a couple of slides of the ball, Monica, in the Alaska exhibition. It was very lightweight, just laying in its cradle, that you said did not move out. You remember that?
Yeah, but I think that goes back to what Vincent and BJ both and Mac brought up, is that those cases were bolted to the cement floor, so those cases didn't transfer, and they didn't move in the same way. I really don't know why the objects on the third floor of our Chipperfield edition, which is the moving kind of building, why they didn't, but we didn't have objects that were in cradles move out there as well. And it might be that just that particular earthquake didn't cause a big jump, or the building absorbed it, or you know, there's lots of things that could have happened. The ground, like below the building, also, and how the foundation is. But I think Jamie had something to say.
Yeah. Well, I was kind of wondering, you know, it ties into all of these things of displacement, the ability to move side to side or whatever, which you showed in the pickle forks and things which weren't tied to the glass shelf. And I know the Getty has worked for years to be making isolation, base isolation. And so there's these, you know, kind of two different ways of looking at it in terms of tying everything down and holding on real tight, or letting things move around and trying to keep them from their writing moment, from tipping over. And do people have, I mean, I feel like with small objects, especially with a base plate that has sufficient footprint, you know, that not tying them down can be overall a good thing. And in terms of tying down the base, not, you know, retention on the object is I think always going to be needed. But I just kind of want to throw it out there as to people's theories about when it's appropriate to allow something to slide versus when you want everything all held tightly.
And regarding that question, I had a question for Monica about the objects on pedestals that weren't anchored down to the floor. Did those tend to walk across the room, or did they stay sort of centered where they were?
So depending on the building, so the ones that I showed, they maybe moved at the most a ½ inch. They didn't actually move, but in that particular building. And then on the first floor where those ceramic large sculptures were, those bases didn't move at all. They were on the first floor, and we have a underground garage underneath it, so that there is a basement. But definitely the first floor pedestals did not move. But on the second floor where all those pedestals are secure, we did have a 3,500 pound canning machine, or processing canning machine, that moved a foot. And that was a big heavy object. And prior to this, I was like, oh, it's never gonna move. We don't need a mount. And obviously not very smart on my part. Should have consulted an engineer. And but luckily it was on its own. It you know, it moved a foot, but it all it did was scratch the deck. It didn't go anywhere. It didn't tip. It didn't hit anything else, I should say.
It didn't fall off of its pedestal. It didn't move.
No, it was on a very large, low platform again. But yeah, yeah. And I don't know about other people's experiences with their buildings and with their pedestals when they've had earthquakes, or their memories of what that might be. That'd be interesting to hear.
I'm going to have to call time, unfortunately. Thank you guys so much. Over to you, Mac, to round us up.